Hey there, folks. So, I know last episode we were working on some of the equipment system. I do want to continue with that. However, there's been a couple of things that have been pointed out to me that are some bad habits I've got that I've been unfortunately sort of doing within the series. Now, these bad habits, I will point out at the start, these are a result of what I do for a profession. Because I maintain and do minimal upgrades on legacy code, and for like that, I'm talking about code that's like 15 to 20 years old. Basically, I do the bare minimum to code changes to keep things working as code breaks with modern compilation and stuff like that. But anyway, so there's been a lot of bad habits that I've done as a result of me not working with modern C++ in my profession. Right here, I actually fixed one of these, but it was, you'll have noticed throughout the series when I'm closing out functions, I'll put a semicolon at the end. Those aren't actually needed. This was one I fixed because I just, for some reason, my brain told me they were needed, but I fixed and tested with a build. One of the other big things I've been doing is things like this: const int reference variable name. I've done this throughout the entire series. This is a bad habit of mine. It was pointed out in a comment. I do apologize who made that comment. I've forgotten who you were. I want to say it was Leviathan something, but I do apologize. I'm sorry. You did comment on it, and I agreed with you when you mentioned it. You don't need to do this. I have a habit of, I do things like that because I work with code that we're more concerned about memory usage versus clock cycles. The hardware things are run on, we have CPUs that are very rarely even at 10%, but we have low memory access or availability in comparison. So it's a bad habit I've picked up where I worry about making sure memory stays at a bare minimum footprint versus overusing CPU cycles. And to explain that, passing in a primitive data type as a const reference requires some CPU cycles to do some validation on there. I briefly mentioned it in the past that it checks, okay, is this valid? Because it's a reference. References cannot be a null pointer. So in doing that, we're adding CPU cycles in exchange for not increasing the memory footprint. Ultimately, the memory footprint of your primitive data types, so that's things like ints, floats, bools, potentially doubles, but the memory footprint versus the CPU cycles in a modern system, it's not worth it. So, as I said, this is a bad habit of mine that I've been doing. I'm not going to go through and record me making changes to every single case of this, but this is for anyone who has been paying attention to the series. You're going to see going forward things like this is just going to be changed to creating a copy. Now, I'm not going to do this for every single parameter. The reason being is it is only your primitive data types that it's more well, I don't want to say cost effective. It is a better trade-off to use primitive data types where we copy them versus more complex. So like in f text, I'm not going to change those. But an integer, a boolean, things like that, the only time I'm not going to change this is if we're passing it by reference for the purpose of actually, excuse me, modifying it, and then returning that information to the function previously, or where it was called from. So like here, these are constructors. We're not passing anything back. We are literally just using them for a data assignment. So in here, I can go through and fix all these up, and it's not going to be that big of a performance impact that it's going to be something noticeable within the game. So a couple of things I wanted to cover right off the start, just simply because, like I said, these are some, I don't want to say very bad habits, but these are bad habits of mine that I've picked up because of the system that I work with and the code I work with. So in here, you're going to see, I'm just going to quickly go through and change all of these out for just a copied version of the variable. So I'm just using this one example here in our fitem UI data as the example for this. And like I said, I'm going to be going through and doing this throughout the project. If for whatever reason you're following along, you make these changes and you end up breaking something, reach out. I may do an episode where I sort of cover, okay, this didn't need to be converted. This should still be a constant reference, things like that. Well, actually, anything that's a const reference can be straight up. It can be just changed back to a copy for a primitive data type. Simply because being a const, you can't change it. So it means all we're doing is pulling that data into a different location. So straight up const references, you can just convert over to just a straight copy. Non-const references, I will say don't change those. Keep them as a reference. With that out of the way, though, let me just pull up my notes here. The next thing I wanted to do is, as I mentioned, circle back to the equipment system. Now, close out of this. Actually, just quickly, so here's another one. Const float reference, you could change that. Now, keep in mind, you have to change it in both the header and source file. So that is something to keep in, be aware of as you're making these changes. You need to do it in both the definition and the declaration of the function. What else was there? There was, oh yes, so there was another cleanup item that was pointed out. Let's pull this up here. It was regarding our buildings. And it was something that came from a comment on an episode. I actually ended up going through, trolling through all my videos, looking at comments, because, as I mentioned in the past, YouTube is not the best. So, was that in here? Or was that in the player character? Oh, that was in the stat line. Stat line component is in building. So, this function here. Building insulation is a float, and we are comparing it against what is effectively an integer. Now, for anyone who's done any work with floats, setting a float to 0 could result in something like, I can't remember how many decimal points a float has, but it can, just with quirks of computers, end up with values like on the screen there, like multiple 0.000001. So because of that, this value might evaluate as, well, in this case, true, incorrectly. So again, I do apologize to who pointed this out in the comments. I need to get better at actually noting down who makes the comments for corrections. But this is another one that you want to change. Sorry, my brain is just not working. Now, how it was recommended, and this is also how I actually figure would be the best way to fix this, is changing this to return building insulation. Thank you, IntelliSense, for moving my caret. To greater than a value. Now, in this case, I'm just going to go 005 because that's 0.5% in the percentile. Because a building insulation of 1 means it's 100% insulation. You're never going to feel weather effects. A building insulation of 0.01 is 1%. So 0.05 is a nice safe value to use because that's 0.5%. If you want to include 0.5%, actually no, I do, thinking about it, you want to use 0.049. So that is, if it is greater than just less than 0.5%, we're going to say you're technically in a building. So that was that one. Yeah, there was one other one here. Where's our environment manager? Our chrono manager. Must have closed it. Okay, so in here, update lighting. This one that's been mentioned to me a couple of times throughout the series. In the environment manager, if you save the game when it is night and reload it, there is some quirks with the skylight where it's not correctly updating in the environment. I honestly don't know if this is the fix. It's something I'm going to test. But what I've done as an attempt to fix that, and I need to do some more digging into lighting. It can get pretty complex with an Unreal Engine. But what I've done is similar to what we did for the render state of objects, things like our trees and stuff like that, where we're forcing the engine to re-render. Right at the end of our update lighting function, I've added in this one here that I've got highlighted. Skylight, get light component, mark render dynamic data dirty. From what I could find online, this was the function to use to force it to recalculate lighting. I didn't actually look for a recalc function, actually. Skylight, get light component. Helps if I could spell. Recapture. But yeah, what I did is I just went through and I typed in what were some keywords. For the one I found, mark render dynamic, I used render. Yeah, it was, I looked up render and can have a render. Where was it? Actually, this was the other one. Actually, I'm going to set both of these. Now, I don't know if either of these are going to work. Mark render state dirty and mark render dynamic data dirty. This one might actually do everything we need. So, well, actually, this would be a good case of showing you how I dig into things, because instead of just sitting here, oh, it might work, I'll actually go through my own process of learning and digging into things. Now, obviously, you have the API documentation available online. Sometimes it's not great. What I like to do in cases like that is, in this case, right-click on the function, go to definition. Now you can see here it takes us to an actor component, mark render state. If registered and has a render state to mark as dirty. If it's registered, render state created, everything there, render state equals dirty, mark for needed end of frame recreate. We're doing that. Okay, so what does this do? Go into there. U actor component, B never needs render update, dropping out. Getting world, component world. So if it's valid, this could be refactored to if whatever, but this is Epic code. I'm not touching it. By convention, recreates are always done on the game thread. Okay, so this might not be the best because we're pushing this to the game thread. component, mark active component for needed end of frame update. Okay, let's go to that. And this goes into a level tick function. Okay. What are we passing through? Requires game thread, end of frame recreate. Well, let's go into this. That is force game thread. Okay. Well, let's see what that returns. And this is how I go about things. So sorry, let me rephrase it. This is how I go about digging into things when the API documentation online isn't clear. There isn't something for it, because there's a lot of things that the documentation just isn't there for either. So, okay, so this always returns true, and we were just up here, so we know it is our skylight, and we're passing through true. So, okay, this is true. It's down here, so check post-it complete update, current state equals, component equals 5, current state equals marked, and be force game, so, and true. So at this point we know this is the only evaluation we're doing, because this part is going to be true based on our code we've looked at. Array index, get array index for the component, check components that need to frame up is valid index. Okay. Array index equals, making sure they are one and the same. This personally, I don't think this one is needed, but obviously it's Epic. They know their engine better than me. Oh, could be, I know, no, that is needed, because that's a potential mismatch between two different indexes. No, it's the same. Anyway, so we're clearing it out so it's not there anymore, and then we're setting it as unmarked. Okay, so what are we doing there? Current state unmarked. Okay, so just looking through this. Yeah, so it's just basically going through and saying, okay, at the end of the render frame, we'll add this to the recalculation at the end of the render frame. So that should hopefully fix the issue. So what I'm going to do here, I understand I was going to circle back to the equipment system, but I wanted to get some of these corrections done. What I'm going to do here is I'm going to run a build. I'm going to pause the, actually before I run the build, I see there's an error in my error list. What are you complaining about? Oh, that's in this page here. What are you complaining about? Well, I'm not worried about that. That's engine code. But yeah, so with that, we got some warnings in here. I'll ignore those. But yeah, so I'm going to run a build. Hopefully this all goes through. We're going to hop into the editor and we're going to take a look at this skylight rendering stuff, just simply because it's something we need to try and address, because again, it's something I've noticed. The lighting isn't being updated properly on a load when you're playing it, when you saved at night. So I'll be back as soon as this build finishes. Alright, so we are in the editor here. There was no build issues. Now, the first thing we're going to want to do, just because of this lighting issue, we are going to want to go to our, let's open up the map here, our persistent map. So this is the one that starts off, that loads the main menu. So once that opens up, so now we're going to do play in editor. This should hopefully open up the main menu. It's been a while since I've done this, so it could have some issues there. Okay, so here you can see new game, load game, options. You will notice I do have some updated buttons here. The reason for this is I've gone through, created some, well, I shouldn't really say I created. These are some open source ones, royalty free, that I found. I can't remember where I got them. I've had them for a number of years. I just wanted to get something in here beyond the basic buttons that Epic gives you with the Unreal Engine. So, new game. You can see here I've done the same thing. I haven't done anything with this background. Day length, 30 minutes. It's going to be a little longer than we need. So, how do we want to go about that? We'll leave it like that. I'm going to leave these disabled and we're going to hit start. So in here you can see we've loaded in. We have shaders still compiling, obviously, because we haven't loaded into this map. And there's pre-compiled shader logic, which I'm going to be covering at some point in the future, which helps this not happen, where things don't load in properly right at the start. So let's look at our chrono manager here, though. I can't even remember. It's been so long, I can't remember if we've got this where I can tweak any of these. Day length in minutes 30. Let's change this to 5. Does that speed things up? Yeah, let's change that down to 1. Yeah, it's not changing anything. Max on intensity. Yeah, so what I'm going to do is I'm going to take this section of the video. I'm going to obviously speed it up really fast until we get to our night cycle. So hopefully that doesn't take too long. All right, so I'm recording this after the fact because I muted my mic to get the time lapse. I didn't want any background audio, and I forgot to unmute it. So going through, you can see we have nothing but really black. Our skylight's not working. So that tells me we have an issue with the code that we added for the skylight update. I'm going to remove that, but let's take a look at the load game now. So again, hindsight's 2020. You can see we have an issue. We're not actually loading in the save information properly. And you can see we have a little error in the top left. That is actually a good telltale sign. Set player data unable to find interface. Now, digging into that, I found what the problem is there is we have some issues with our load game logic. Things are being done out of order, and that is because the call for load game actually ends up hitting a asynchronous function, which causes our C++ logic to continue. So right here you can see I'm still going through and we're checking out this load logic. Things aren't working. We hop over. We're not hitting this set actor raw data, which is part of the load game process to set the time information on the chrono manager. So going through that, we're taking a quick look at our game instance now. See, I throw a breakpoint on the start of it, run through, try to load the game. We hit this. Now, this process takes a little bit for the debugging to hit my breakpoint and actually let me start doing things. But I'm going to explain through this. Pause the video here quickly, just long enough to get rid of this really long debug operation. But to explain, we step through, we get down to, actually no, I throw a new breakpoint in here. So we get to our savable actor data, clearing that out. We get to our save game object where we load in the save game. Now we're pulling out the savable actor data from that save game object. And here's the debugger taking another long period of time to let me get through into the next step. But so anyway, so we're pulling this in. I'm going to throw a breakpoint and then a add watcher. Sorry, not throw a breakpoint. I add a watcher here to the savable actor data. And the reason being for that is we want to take a look at it, and IntelliSense being itself, we're not able to do that just by hovering over in the code itself. But in here, you can see we have 6 actors. It's actually index 0 that is our chrono manager. You can see it's got current time. All of that information is in there. I'm digging down, trying to see and confirm, is this the right actor? Doing it on a couple of different ones here. And just looking at some information just to see. This one is pulling up that you can see, yeah, we have our current time struct, which is a save game object. Now, that doesn't get saved properly, but it is also in our raw data. So, going through this, and again, I'm sorry, I'm dictating this after the fact, so I'm trying to remember everything I covered. Actor class, we just have class. Not worried about the transform or anything like that. So now we're stepping through. We're now for, I'm going through the cleanup code here, which we don't need to actually look at. And scroll down to where we start actually applying the information, which is right here. So add a breakpoint there, and then hit continue. Step through. Actually, go to add a second watcher to this. We don't need to. It's already in our watch list. Hit continue. You can see it's a brush, and here's where I add that watcher. Don't need to. Minimize that savable actor, and you can see it's there at the top. So we actually have 2 watchers for the same thing. Brush. Oh, I got the breakpoint in the wrong place, so I'm going to hit there. Default physics volume, gameplay. We go through and notice there's a bunch of different things in here that aren't related to our game. And this is why we have the if is valid actor component or is not. But you can see through, we go through all of these, and this list, we're going to drop out of it in a second here, doesn't actually contain a chrono manager or any of the stuff we need. And you can see right there we have the main menu object. That is telling us this is being called while the main menu is still loaded, which is what's going on here. We have an out of order operations issue where we have code being called before it should be called. Now, I'm going to end up ending things off here. The reason being is next episode is going to be covering this in its entirety on how to fix this one. Now, obviously, this is going to be a quick patch to get things fixed because we are still early stages in development. But moving forward, we're going to actually have... I'm going to be digging into some better load game logic because right now I'm leveraging a mix of C++ and blueprints, and that is ultimately where this is coming from. So, as always though, folks, if you have any comments, questions, concerns, suggestions, or you notice I'm doing anything with bad habits that don't line up with modern C++ standards, please feel free to leave them in the comments below. I'm going to correct myself wherever I can. But as always, thank you for watching, and I will see you in the next video.